In this lesson, we're going to talk a little bit about right triangles and the trigonometric functions. So first we're going to talk about sine, cosine, and tangent functions, and they're all based on a right triangle. So all of these things that we're going to say are only true if you have a right triangle. And when you look at your triangle, we're going to talk about one of the two angles that are not a right angle, and it's very important to label the sides with relation to a given angle. So if we know theta, as we do in this diagram here, if we have theta, opposite of theta, or across from theta, is called the opposite side, and next to theta is called the adjacent side. Of course, the side across from the right angle, as we've said, is the hypotenuse, and that one doesn't change. However, if we were to talk about the angle on the top of this triangle, and if we call that beta, well, opposite of beta would be over here, so this would now be the opposite side, and adjacent to beta would be here, and we would call this one adjacent. With relation to beta, this is opposite and this is adjacent. With relation to theta, this one was adjacent and this one's opposite. So the names of the sides change depending on the angle you're talking about. So it's very important when you see sine, cosine, tan, when you write sine, cosine, tan, that there's always an angle following, because that tells you which part of the triangle you're talking about, or what is opposite of that angle and what is adjacent to that angle. And the hypotenuse, of course, is always in the same place. And so we have another diagram here which shows the same thing. If we talk about the top angle in the triangle, we have opposite and adjacent. But if we talk about the base angle for this one, this would be opposite and adjacent, and it changes as the angle changes. What the importance of knowing the opposite, adjacent, hypotenuse is, and why we need to know that, is because that's how the sine, cosine, and tangent functions are defined. So the sine function, sine theta, is defined as the opposite side divided by the hypotenuse. So it's simply a ratio of the length of the opposite side divided by the length of the hypotenuse. The cosine is the adjacent side divided by the hypotenuse, and the tangent function is the opposite side divided by the adjacent. Again, all in relation to the angle that we're talking about. Some students have seen this, a word called SOHCAHTOA. SOHCAHTOA. So we can use SOHCAHTOA to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We're going to use sine, cosine, tangent functions a lot in this chapter and this topic of the course, so it's very important that you have a good handle, a good idea of how to use those. We also have secondary functions, and I'll just briefly mention these here. And secondary functions are called cosecant, secant, and cotan, or cotangent. And those are CSC, SEC, and COT for abbreviations. And these are actually reciprocal functions. Remember, reciprocal was 1 divided by, or flip over something that you had before. Divide something into 1. Well, the cosecant is the reciprocal of sine, so we say that's 1 divided by the sine function. Secant is the reciprocal of cosine, so that's 1 over the cosine function. And cotangent is the reciprocal of the tangent, so that's 1 over the tangent function. And if you look at what we did a minute ago, sine was opposite over hypotenuse, then the reciprocal would be hypotenuse over opposite. So we can also remember the rules for the secondary functions. Your calculator is only going to be able to do sine, cosine, tangent, the primary functions. So those are much more common, but these do turn up from time to time, so they are important to know when you see SEC, what that means and how to relate it to cosine and how to evaluate it. Again, as with sine, cosine, tan, they're dependent on the angle, so we see each one has the angle theta. So opposite refers to, in this case, across from theta, and adjacent next to theta, and the hypotenuse, of course, is opposite of the 90. We're going to stop that lesson there. In the next lesson, we'll do some examples of using each of the different rules. For now, that was just a brief idea of what the trigonometric functions are and what the rules are. So go to the next lesson, try the examples, and if you're having any problems, then is the time to get some help. So we'll see you in the next lesson.